Hello, this is Dr. Rhodey, and in this tutorial, we will show how to use Excel 2010 to perform an independent samples t-test for the difference of means. The particular test we're going to do is the independent samples t-test with unequal variances or unpooled. In this example, we have a dietitian who performed a pilot study of whether a prepackaged managed meal program will result in lower blood sugar levels in type 2 diabetic patients than the American Diabetic Association recommended meal plan. To avoid confounding by race, gender, and age, she performed her study on a random sample of 30 male Caucasian subjects aged 40 to 45 diagnosed with type 2 diabetes. 15 subjects were randomly selected to follow the prepackaged meal program, and 15 subjects were randomly selected to follow the American Diabetic Association meal plan. After 6 months on their respective plans, hemoglobin A1C levels, a metric of long-term blood sugar levels, were measured for each of the subjects and are displayed in the table below. Is there evidence at the 5% level of significance to suggest that the prepackaged meal plan results in lower blood sugar levels than the American Diabetic Association diet? So, in this example here, we have our columns of data. In this first column, we have the A1C levels for the 15 subjects that used the prepackaged meals. And in this column, we have the A1C levels for the 15 subjects that did the American Diabetic Association diet. And we wanted to figure out, is there statistically significant evidence to suggest that the prepackaged plan results in lower blood sugar levels than the ADA plan? Well, our null hypothesis here would be that the average A1C level between the two groups would be equal to each other. Or another way to look at it is that the difference in the averages between those groups would be equal to 0. Our alternative hypothesis would be that the average of the prepackaged group would be less than the average of the ADA group. Or the difference with prepackaged average minus the ADA average would be less than 0. Well, to perform the calculations for the analysis, we're going to use the data analysis tool pack. I go up into here to the tab right here for data. Then on the far right, you see the button for data analysis, and this is the data analysis tool pack. And I have all these different things I can do. And what I want to choose is the one that's already highlighted here, t-test to sample assuming unequal variances. You would only do the equal variances if you had overwhelming evidence or some reason to believe that the variation between the two groups is the same, the standard deviation or the variances. Sometimes this is called pooled. What we want to do is the unpooled, the unequal variances. Because in this case, we have no reason to believe that the variances would be equal to each other. And most of the time, this is the test that you want to do. So I'm going to hit OK. Now I'm going to choose my variable range for the first variable and the variable range for the second variable. What I want to do is tell the function where the data is. So I want to go to this button here and click, and it'll let me go back to the spreadsheet, and I'm going to highlight this column of data. Now I am including the label here, and I'll explain what impact that has. You could choose not to include the label. I chose to do it. So I'm going to click here. Then I go to variable to range, and I highlight this column all the way down to the bottom with all the 15 numbers and go back. Now the hypothesized mean difference, that's our null hypothesis, and we're making a null hypothesis that the difference in the average A1C level between the two groups is 0, so I put 0 there. This button here, I'm going to click that on because I included these data labels in my ranges here. And this way, when the output is produced, it'll show these headings. You don't have to do that. It's your choice. But if you do, make sure you click the labels button to get the proper calculations. The alpha, that is my significance level, and that's 5%, 0.05. So now I have to choose where I want to put my output. I can have it open a whole new workbook or just a new worksheet. I'm going to go and put it on the same page. So I click the dialog box right here for output range. Then I go to this button here to go to the spreadsheet. And what I want to do is just point to where I want the left-hand corner of the data table, the output table. So I'm going to put it right there. Now I'm all set up and ready to run the calculation. So I'm going to hit OK. And here is my output for the two-sample t-test assuming unequal variances. The average for the prepackaged group here is the 6.51, rounded to 2 decimals. Here for the ADA group, it's 6.6. So it is lower, but we want to determine, is it lower enough to be considered statistically significant? Well, the way we do that is we look at the p-value, compare it to the level of significance. If the p-value is less than the level of significance, then we have statistically significant evidence to reject the null hypothesis in favor of the alternative. And in this case, the null hypothesis is that there's no difference, and the alternative hypothesis is that the prepackaged plan has lower average blood sugar levels than the American Diabetic Plan. Well, I have two types of p-values. I have a one-tailed p-value and a two-tailed p-value. So to figure out which one to use, you consider the type of alternative hypothesis you have. In this case, our alternative hypothesis is less than. Do we think that one group is lower than the other? So that is a one-tailed p-value. If I was going to use the two-tailed p-value, the alternative hypothesis would simply be a not equals. And that would be an analysis of whether there's just a difference exists at all, rather than specifying if it's greater or less than. But since we are specifically asking, are the prepackaged A1C levels lower than the ADA levels, has an alternative hypothesis of less than, so I'm going to use the one-tailed p-value. My p-value here is 0.395 and so on. Well, that is much larger than 5%. So I would fail to reject the null hypothesis. In this case, I do not have significant evidence to suggest that the prepackaged meal plan results in lower blood sugar levels than the American Diabetic Association diet. What this means is that according to this data and in this study, the probability that I would randomly be at 6.5 compared to 6.6 just due to random variation, that probability is about 40%. So about 40% of the time you would have a difference this large between the two groups just due to natural variation, regardless of what plan they used. And since that's such a large probability, and it's likely that that just could occur just out of luck, there is not evidence here to suggest that the plan is effective in having a lower blood sugar level than the American Diabetic Association plan. If this probability was really tiny, then we could say, well, the probability they randomly were that low is so small and so rare that we feel that it's not due to random effects, but rather because there is something about the prepackaged plan that does result in lower blood sugar levels.